The rest of the gas laws that you are going to see are dealing with changes in some of the four measurements you saw in the ideal gas law. So Boyle's law deals with two of the measurements as variables that change and two of them as constants. The variables changing in Boyle's law are pressure and volume. Well, the constants then are moles and temperature. We get the equation from the original ideal gas law equation that stated that our constant was the pressure times the volume over the moles times the temperature. If moles and temperature are constant, we can ignore them because we're looking at a change. So essentially we're looking at the pressure initially and the volume initially, we'll label them with ones, divided by the moles initially and the temperature initially, will equal the same constant. So we could say a new pressure, a new volume, a new moles, and a new temperature. If moles and temperature are constant, though, we can ignore them in our equation. So the equation for Boyle's law is the initial pressure times the initial volume will equal the final pressure times the final volume. Since they are being multiplied, they have a specific relationship that you could see on a graph. As the pressure increases, so if P1 increases as it goes to P2, in order to get the constant, the same value, the volume would have to decrease. So as one increases, the other decreases. This is an inverse relationship. It's really important that you understand what an inverse relationship is. As one increases, the other will decrease, and it works both for pressure and volume. So let's do an example problem. Let's look at number 1 in your packet. It says a sample of gas has a volume of 460 milliliters when measured at 35 degrees Celsius and 740 millimeters of mercury. What volume in milliliters will the gas occupy at the same temperature and 175 millimeters of mercury? In order to do these problems, we really need to write out our givens, and we need to be very specific about initial and final values. In this problem, we have a volume initially of 460 milliliters. We have a temperature initially of 35.0 milliliters and a pressure of 740 millimeters mercury. The question is what volume in milliliters, so what is V2, when the gas is at the same temperature? So T2 is 35.0 milliliters. If it's constant, we don't care about it. It doesn't affect our equation. Our pressure changes to 175 millimeters of mercury. Here's where you should first estimate what's going to happen. The pressure goes from 740 to 175, so the pressure is decreasing, which means our volume should increase. Okay, that's one way to kind of check your answer. So we write out our equation. P1 times V1 equals P2 times V2. What a lot of students like to do right here is plug the numbers in and then solve for V2. I find that students do better if they do the algebra with just the symbols. You actually are writing less, which everyone likes to write less, and you are less likely to make a mistake. So solving for V2, I need to divide both sides by P2. So it divides out over here. So V2 equals P1 times V1 divided by P2, and then I plug in my numbers. Be very careful with those subscripts, P1 versus P2. So my P1, 740 millimeters of mercury times 460 milliliters divided by 175 millimeters of mercury. Now, units. Make sure you're writing your units in your problem. So this is another way to check your answer. Millimeters of mercury will divide out. You're left with milliliters, which is what you want for a volume. In the ideal gas law, in order to use that, the volume had to be in liters. For these, it does not have to be in liters. You can leave it in milliliters. It can be in liters. You just have to make sure your two volumes have the same units. So punch this into your calculator. You should get an answer of 1,950 milliliters. You can only have 3 significant digits. That's why it's 1,950 milliliters.